Types of numbers. There are many types of numbers. The ones we will be focusing on in this lesson are whole numbers, natural numbers, integers, rational numbers, irrational numbers, and real numbers. Whole numbers. These are the set of numbers starting at 0 and goes all the way to infinity. This set is denoted by a capital W. It does not include fractions, decimals, or negative numbers. Example: the set of whole numbers equals 0, 1, 2, 3, 4, 5, and it goes all the way to infinity. The 3 dots means that it goes on forever. Natural numbers. These are the numbers which we use for counting. This set of numbers is denoted by a capital N and does not include 0. So, natural numbers are also known as counting numbers, and these are the numbers which we use in our everyday life. For example, if our friends give us 5 oranges or 2 apples, the digits 5 and 2 are counting numbers. All natural numbers are whole numbers, but all whole numbers are not natural numbers. So, as we learned earlier, whole numbers includes 0. It starts at 0 and goes on forever. But for natural numbers, it starts at 1 and goes on forever. So example, the set of natural numbers, which is denoted by a capital N, equals 1, 2, 3, 4, 5, and it goes on, it never ends. Integers. Integers are the set of numbers including negative numbers, positive numbers, and 0. Negative numbers are numbers that are less than 0, while positive numbers are numbers that are greater than 0. There's one thing to note, and it is not because you see a number with a negative sign, that doesn't mean it's an integer. For example, if we have negative half, that's not an integer. If we have negative 0.5, that is not an integer as well. If we have negative 0.25, that is not an integer. So bear that in mind. Integers do not include decimals or fractions. Yes, I explained that a couple seconds ago. This set of numbers is denoted by a capital Z. Example, the set of integers Z equals negative 4, and here we have the 3 dots, which implies that it goes on forever in the negative direction. And as we know, negative numbers are less than 0. So here we have negative 4, negative 3, negative 2, negative 1, 0. Then we have positive 1, positive 2, positive 3, positive 4, and it goes on forever. Integers includes whole numbers, natural numbers, and their negative counterparts. Rational numbers. A rational number is any number that can be written as a fraction or ratio. It can also be defined as any number that is obtained by dividing an integer by an integer. The divisor cannot be 0. The divisor is the number which is used to divide the other number. That's a definition in simpler terms. Rational numbers are denoted by a capital Q, such that Q equals common P over common Q, where P and Q are both integers and Q is not equal to 0. And note, this is common P and this is common Q. So Q is not equal to 0. If you divide a number by 0, that is undefined. So that's the reason why Q cannot be equal to 0, because that would be undefined. Terminating decimals and non-terminating decimals with recurring decimal expansions are also rational numbers. Examples of rational numbers. Here we have 2 over 9 equals 0.222. The 3 dots, as we explained earlier, signifies that it goes on forever. So we can see that this decimal expansion is recurring. It's a recurring, non-terminating decimal. So it repeats itself and it goes on forever. This is a rational number. -7. -7 is also a rational number. See, it can be written in the form P, common P over common Q. 0.25. 0.25 equals a quarter or 1/4. This is a terminating decimal, and as we explained in our definition, this fits the description for a rational number. Here we have 4, can be written as 4 over 1. Now we have the decimal 0.142857, 142857, 142857, and it goes on forever. This is a non-terminating recurring decimal. See, 1, 2, 3, 4, 5, 6. 6 digits repeats themselves. And this can be written as 1 over 7, or 1 divided by 7, in the form P, common P over common Q. The square root of 16, the square root of 16, which is 4. So as you can see, this is also a rational number, because the 4 can be written as 4 over 2, 4 over 1, etc. 10 over 2 equals 5. These are all rational numbers. So as you can see, it can be written in the form P over Q. Good. Let's look at 1/3 equals 0.3 with this line above the 3. In truth, Dividing 1 by 3, you get 0.333333333, and it go, you can say 333 from now until forever. To write this 0.3333333 in simpler forms, we just put the line over the digit, the line or the bar over the digit that repeats itself. So, with that being said, the line above the 3 signifies that the 3 goes on forever. Therefore, from our example, 1 over 7, or 1 divided by 7, equals 0.142857, 142857. 142857 can be written as 0.142857 with the line above. So this implies that this decimal expansion, it goes on forever. Irrational numbers. These are the set of numbers that cannot be written as a ratio or fraction. Their decimal expansions goes on forever without terminating or recurring. So one difference is to know that irrational numbers, their decimal expansion, it goes on forever. However, it does not recur. So it is non-terminating and non-recurring. They cannot be written in the form common P over common Q. That's the other thing to note about irrational numbers. The square root or cube root of numbers that are not perfect squares or perfect cubes, respectively, are irrational numbers. Irrational numbers are denoted by Q prime. Let me make this symbol clear. So it's Q prime. Example. We have the square root of 8. 8 is not a perfect square, therefore this is an irrational number. We have the square root of 5. 5 is not a perfect square, therefore this is an irrational number. The square root of 11, not a perfect square as well, so it is an irrational number. The cube root of 19, this is not a perfect cube, therefore this is an irrational number. Question. Let's say we had the square root of 64. Is that an irrational number or an rational number, or a rational number, sorry? It is a rational number because the square root of 64 is 8. 8 times 8 is 64. And the digit 8 can be written as 8 over 1, 8 over 2. So therefore, it is a rational number. A rational number. Let's say we had the square root of 25. Is it a rational number or a irrational number? It is a rational number. Good. The square root of 25 is 5. 5 multiplied by 5 is 25. And the number or the digit 5 can be written as 5 over 1. it can be written in the form P over Q. Therefore, it is a rational number. Good. So other examples of irrational numbers are Euler's number, which is represented by this fancy E, pi, and the golden ratio. Which is represented by phi.